More rules on exponents and how to deal with them. Today we're going to be dealing with multiplying powers with the same base, meaning if you have two things that are the same number or the same variable and you multiply them and they have exponents on them, what do you do with their exponents? So what do you do to get to an answer on this? In order to do this, you have to follow some more rules about exponents. It says to multiply powers with the same base, you do what? You are going to add, that's a really weird start to that. Add the exponents. That's it, guys. Add the exponents. Now we're going to add the exponents. We're going to subtract the exponents. We're even going to do some other things with them. So you need to know what the rules are. When you're multiplying, you're going to add the exponents. So if you have a problem that looks like this, a to the third times a to the fourth, a to the third times a to the fourth, really all that is a to the 3 plus 4, which means it's a to the 7th. It's very tempting to multiply them, and that's what you do on something else, so be careful. When you're multiplying like bases, you add their exponents. Multiply like bases, you add the exponents. So down here I use the exact same numbers, 4 and 3. We've got a base of 3, so this would be 3 to the 7th. Just add them. All you do is take these numbers, add them up. That's it. Now, sometimes they will ask you to leave it in this base. Sometimes they might ask you to simplify it out to a final answer. If they ask you to leave it with the base one time, you'd leave it like this. If they wanted an answer, they'd say simplify it all the way. And so if you did, you do 3 to the 7th on your calculator and get an answer, but this is just going to be writing it as a base. Okay, let's keep going with this rule. Again, guys, when you multiply like bases, you add their exponents. So 0.5 and 0.5 both have that same base, so it's going to be 0.5, and then you add their exponents. You add the 2, you add the 4, 2 plus 4 puts you at 6. That's it, guys. This is not crazy math. It's just you got another rule. Okay? The next one, we've got an 8 for the base for each of these. That's going to make it 8 to the, well, we add those powers. That's 8 to the negative what? Negative 10. The only problem is, can we leave negative exponents in our answers? No. So you've got to do the whole thing that we did yesterday. This is where I told you it builds. We use yesterday's stuff to do today's stuff. So if you do that, you put it over 1. You draw a new fraction bar. The 8 is going to have to move to the bottom. So it's going to become 8 to the 10th down here. And what do we put on top as a placeholder? A 1. Perfect. Okay, guys, even if you have 3 of them multiplied, see they're all the same base. This only works if they're the same base. The base is 9. And we want to combine all these. We want to add these exponents all together. So you can do it on a calculator, do it in your head, do it however you want to, but you got to add all these up. Negative 3 plus 2 plus 6. What do you get when you combine all those? 5. 9 to the 5th. There we go. Anybody have any questions about the rules before we start adding in some coefficients or anything else in front of it? Yes, thank you. If they want you to simplify it, yes. They also might want you to leave it as a base, as a single base. It would ask you specifically to simplify it all the way out. If it asks you to do this, what they're working on is the rule for the base. They'll use variables for some, numbers for some. You'll see what I mean as I keep going. If they have it like that, what they're looking for is you to keep the base in there. Yeah. It just depends on how they ask the question, is what I'm saying. Anybody else? Okay, let's keep going. So, guys, when you add in multiplication that you've been doing since like 3rd grade, don't start going crazy and doing weird stuff. You've been multiplying 9 times 4 since you started learning the times tables in 3rd or 4th grade. Okay? 9 times 4 is going to put you at 36, just like it always has. Do not change that process. Do not start doing anything weird. Just multiply the numbers. Then you're going to take the like bases and you're going to add their exponents. 5 plus negative 12 is going to give you an exponent of negative 7. Good. Can I leave my answer like that? No, because it's got a negative exponent. I'm going to put it over 1. I'm going to draw a new fraction bar. Does the 36 move? Does it have a negative exponent? No, it's going to stay on the top. Does the z move? It's going to move to the bottom and become z to the 7. Perfect. Perfect. That's it. Okay, guys, when you're multiplying, you're going to multiply all these things together, whether they have the same variable or not. Oh, I'm sorry. Yes, sir.
So they're not all raised to that negative 7 power?
I can't hear. I'm sorry.
So they're not all raised to the negative 7 power?
They're not all raised. I don't understand the question. Help me understand. Keep asking a different way. Someone help.
The 36 is it not, they're both not raised to it.
You mean the 36 and the z? Both? No. It would have to have parentheses for them to both be raised to the negative 7th power. That's a very good question. I didn't understand what you were asking, but thank you for keeping going. Guys, if I don't understand what you're asking, please keep asking the question. It's not you, it's me understanding how you're asking. I just like I explain things over and over in different ways. Sometimes people get it from one, some another. Please keep asking. Thank you for asking that question. The answer is no. It would only work that way if it had parentheses around it and that negative 7 was on the outside. It's a very good question because we're going to get to that in a minute. So, very good question. Okay, guys. When you have different terms, it doesn't matter. You don't need like terms. We did that already when we first started combining variables, when we were adding and subtracting. When you're multiplying and dividing, you don't need like terms. Some of y'all start getting panicky here when you're multiplying. It doesn't work that way. If you've got multiplication, you've got to multiply all three of these. 2 times 9 times 3. Do that on the calculator. What's 2 times, what was it? I'm sorry. 54. Perfect. Then you start looking alphabetically and you combine the ones that alphabetically have the same base. This is an A, this is an A. You put the A as your base. What is the power right here, even though there's nothing written here? 1. So 1 plus 2 is going to give you a power of 3. Then the b to the 4th goes at the end, and you don't do anything to it because there's no other b to combine it with. Questions? Okay, we're going to do more. I got 2 more of those because I knew that's a little bit different, so I wanted to get some more of those. So grab your calculators, do negative 4 times 7 times 2. Negative 4 times 7 times 2. What do you get? Negative what? I'm sorry. Negative 56. Okay. Alphabetically, the C comes first. So C goes right here. We're going to be adding this 3 and this negative 2. Oh, guys, what's 3 and negative 2, though? 1. Do we write the 1? We just write C. We just write C. And then the D to the 2nd goes at the end. Don't forget the D. Don't forget to put that on the end. Okay, anybody else? Okay, here we go. Next one, guys, you see there's only a 12. It's a number. It's the only number. It goes in front. You don't do anything to it. Really, what numbers are here? 1. So 1 times 1 times 12 is 12. And then alphabetically, J is going to go first. What power would the J be raised to? 2 plus 1 puts you at J to the 3rd. And then the K to the negative 2 is going to go right here. The only problem with that is we cannot leave negative exponents in our answers. Because of that, we've got to put a fraction bar. We've got to draw a new fraction bar. The 12 is not going to go anywhere because the 12 has no exponent on it. It actually has a 1, but we don't show it. The J has a positive exponent, so we are going to leave it on the top. The K has a negative exponent, so it is going to move to the bottom. Concerns, questions, anything before we go to our next step, which is the basics of scientific notation and multiplying scientific notation? No? Okay, here we go. So, guys, to multiply with scientific notation, it says you multiply the number, multiply numbers in front. Multiply the numbers in front. So you're multiplying this, two numbers that are here in front. So we're clear on what I'm talking about when I say that. Words don't mean anything if you don't know what they mean. Right. Multiply the numbers in front. And then you see the base 10s are the same. So you're going to take their powers and add them because you're multiplying like bases. So the next thing is going to be to add the powers on the base 10s. Add the powers on the base 10s. Add the powers on the base 10s. And the last step is the one that most people, this is where people kind of get into trouble. They do the math part of it, and then the science-y, like the scientific notation part is the harder part. The last part is to rewrite in scientific notation. And some of y'all are more familiar with that than others, so we're going to treat it like you've never seen it. We're going to go over it. We're going to talk about where to move things and what to put them in and which direction to go. We'll do that in just a second. Okay, guys, grab your calculators. Multiply 1.13 times 3.34. It's going to give you a longer decimal. It's around 3 point something. What's that give you? 7742. Okay, everybody get the same thing? I just want to make sure we're all on the same page. Yes? Okay. And then multiplied times 10. And then we're going to add these two powers. Okay, 10 to the negative 7th and 10 to the 11th. When you add those, what do you get for a power? 4. There you go. Last step is to rewrite in scientific notation. However, this example was picked for the first one because it's already in scientific notation. Anytime you leave a number in scientific notation, it's going to be a multiplication problem where you have a base 10 as your second part. That has an exponent. It can be positive or negative. And this number always has one number in front of the decimal. Okay? That digit has got to be somewhere between 1 and 9. Listen to me. It's not ever going to be 0 there. It's not ever going to be bigger than 9. So it's never going to be a 2-digit number. It's going to be 1, 2, 3, 4, 5, 6, 7, 8, or 9. That's it. Those are the only choices. That's the only thing that can be in front of here. If it's a bit different than that, you have to move the decimal so that it looks like that. We'll show you that as we get into some problems. We'll tell you what it means to move it. If you move it to the left, what do you do? And if you move it to the right, what do you do to the powers? It affects it. We'll show you as we go. Here we go. Let's do the next one. Grab your calculators. This is 4 times 0.6. 4 times 0.6. What's that give you? 2.4 times 10 to the, and then we add the powers on those 10s. So negative 9 and 5 gives you a total of negative 4. Can we have a negative exponent when we're doing scientific notation? Yes, the only time you can have that on our test. Okay? Now, do we have one number in front of our decimal? So we're good. That is scientific notation. We haven't started changing any yet. We haven't started having to move any decimals. The next one you do, just so you know. We're building up to that. Okay, here we go. Negative 5 times this 7. We're multiplying first. Negative 5 times that 7 puts you at negative 35 times 10 to the, we add the exponents. Guys, add them when you're multiplying like bases. That's going to give you a total of negative 5. Okay, do we have one number in front of our decimal? How many, actually guys, how many are in front of our decimal right now? 2. The decimal point is at the end of the number when there's no decimal. Okay, we need it to be right here. So we're going to draw our decimal point and we're going to put an arrow and go over one place and we're going to make that negative 3.5 times 10 to the, don't write the power yet. Okay, we moved it one place. We went one place to the left. Okay, we move the decimal to the left. Okay, when you move the decimal place to the left, your power is going to change. When you move that decimal place to the left, your power is going to change. It is going to go up by however many places you went. So if you go to the left, your power goes up. Okay? So, since my power was originally -5, guys, be careful. What's 1 up from -5? -4. And that's your answer. Guys, how many places you move it over, that's how much it goes up. If you go to the left, it goes up 1. If you go left 1, you go up 1. Okay, let's do the next one. We'll show you how to do. I think the next one goes the other way. Yep. Here we go. 0.3 times 0.7 is going to be is it 2.1 or 0.21? 0.21 times 10 to the 8, because 6 and 2 is 8. I have an answer where I have no numbers in front of my decimal place. So I'm going to move it 1 place. This time I'm going to the right to make it into 2.1. Does everybody understand? I got to have 1 number in front of my decimal point. That's the whole thing. I got to have 1 there. So if I'm going to move it to the right, my power is going to go down by the same amount. Since I moved it 1 place to the right, my power's got to go down by 1. What is 1 less than 8? 7. There you go. Okay, last one. Here we go. 22 times 8. I have no idea. What is it? 476? 176. That seems a little more reasonable. Times 10 to the 5th. Perfect. 5th. We have 3 numbers in front of our decimal place. We can't have 3, so we've got to move it. We're going to take it from the end, and we're going to move it 2 places to the left. It makes it 1.76. Because we went 2 places to the left, our power is going to go up by 2. And that's going to make it 10 to the 7. Now, guys, think about this. Just because I had trouble on the test remembering when I was your age doing this, trying to do the test. I always had trouble remembering which way to go. But guys, look at this. Anytime you're going to make this number smaller, you made it into from 176 to 1.76. Okay? If you make this number smaller, this number's got to get bigger. If you make this number bigger, then this number has got to get smaller. They got to go the opposite direction. Does that make sense? Okay? That's how once I got that, then I could remember it every time. I'm just trying to point something out to make your life easier. Okay, here we go. Next one. And I cut the assignment way down, you'll see, because I knew we'd have a long time on this, so we don't have a very long assignment. Okay, guys. Simplifying expressions with rational exponents. Guys, we got a fraction as an exponent. Don't panic. Don't make this anything crazier than it is. This is calculator work. We're going to show you what it actually means, but we're going to show you how to type it on the calculator. Okay? 9 to the 1/2. When you see this, this is your power. This is your root. You got to understand what these things are, guys. I understand we're going to type it on the calculator, but you got to know what it means. So it means this is 9 to the 1st power, and it is going to be raised to the 2nd root. That's called a square root. That's probably what you're more familiar with calling it. There's cubed roots, though, that keeps going up. You can do higher and higher numbers there. What that means is you're taking the square root, which you don't have to have the 2 there when it's the square root of 9, because 9 to the 1st power is just 9. And what is the square root of 9, guys? What number, when you multiply it by yourself, gives you 9? 3. Perfect. Okay? So, we are going to use the calculator to do this, though, so that you can learn how to type this on the calculator. Grab them and let's start going. Okay, guys, clear it out. So, you type 8. You hit the little caret. You're going to hit, what is it, 1 fraction button. 1 fraction button 3 equals. Tell me what you get. 2. Okay. Did anybody not get that? Anybody need me to tell you any buttons on the calculator? Now's the time. Try typing it. Let me know. Do it again. Here we go. Clear. Clear, clear, clear. 27. Arrow. 1 fraction button 3 equals 3. Okay, let's do it again. 16 caret 1 fraction button 4 equals, what'd y'all get? 2. 2. What about the calculator about this do you need to ask me about? Anything about it? Because this is the time. Nothing? Okay. This next one's the same thing, guys. It just happens to not have 1 on the top every time. Okay? When it's greater than 1, it's still the same process. This is still going to be your power. This is still going to be your root. When you write it, it'd be 9 to the 3rd power, all to the square root, which means you'd be taking the square root of, what's 9 to the 3rd power do on your calculator? Do the math for that real quick. What is it? What? 1029? 729, sorry. 729. And then take the square root of 729. What's that give you? Should be a decimal, right? I'm guessing. Do y'all know how to type a square root on this calculator? Second, the x squared, 729. Does it give you a nice number or not? 27. Easy peasy. There we go. Hey guys, we're going to do it that way? No, I told you, just type it on the calculator. Grab your calculator, clear it out. I just want you to show you what it means. 8 to the 2/3 means 8 caret 2 fraction button 3 equals. It should give you what? 4. Guys, I'm not hearing a lot of answers to this. If you don't know how to type this, this is like a big thing on the test. You got to ask me how to type it. If you don't know what I'm saying when I say caret, it's the arrow that goes up. If you don't know what I'm saying when I say fraction button, it's the ABC button. You got to ask me questions if you don't know how to use it. Okay, here we go. Yes, please. A square root? Absolutely. If you were trying to do a square root, you'd hit second, and then you hit that little square root button, which is the X square button, that X button key. It puts a little square root symbol in a parentheses on your calculator. You type, let's do 9 because it's an easy number, and it equals. Should give you 3. Got it? Okay. Guys, please ask me, and if it doesn't work when I go over it, I'll get you to come up here. Yes? Yeah, to do a square root or to do this? Square root. Second, the little x2, and then 9 and equals. Should give you 3. Is that okay? Anybody else? Okay, let's keep going. So, for this one, 27 caret 4 fraction button 3 equals. What'd y'all get? 81? Okay, last one. Y'all do it. I'm not doing this last one. Y'all see. Tell me. 8? Does anybody have any problems? Get to 8. When you type through it. Okay, guys. So, calculator work. Got to know how to type these in on the calculator. Got to know how to type these in on the calculator. It's the same thing. These just happen to have 1 on the top. These happen to have a different number on the top. Okay. Okay. Last thing today. Multiplying. More multiplying. It's the same thing, but it's got fractions. I wanted to do this because I want to make sure y'all didn't panic when you got these on your homework. Guys, what's 2 times 2? 4. We got to add this. You have calculators to do this. 3/5 plus 1/5. You shouldn't need a calculator. Y'all know if it's the same base, all you do is put the 5 on the bottom and add the numbers on the top. 3 and 1 is a total of 4. If you add 3/5 plus 1/5 on the calculator, it gives you the same thing. Okay. Same thing on the next one. There's no numbers in front, so all you're doing is putting the n, adding the exponents. What's 1/3 plus 4/3? 5/3. Again, your calculator will do it. If you have trouble with that, come see me up here at the desk. You got to ask me some questions on how to do that if you need to. Yes, sir.
Do you not do when the denominator is given
A mixed number? Never do mixed numbers. Never do mixed numbers. We don't do mixed numbers in this class ever. You can't factor them. You can't, this whole semester, you can't, we're going to start breaking things apart. You can't break a mixed number apart. You have to basically turn it back into an improper fraction of fact to do that. Yep. Okay, here we go, guys. Last one. When you're multiplying this, you're going to multiply the ones that are, you're taking the b's, putting them together. You're taking the c's when you're multiplying, adding their exponents, putting those two bases down here at the bottom. You're going to have a base of b and a base of c. They're going to be multiplied together. You just need to know what the fractions are. Grab your calculator and add. What is 2/3 plus 4/9? What's that give you? What was it? 10/9? 10/9. Is that what y'all got? I just want to make sure we got confirmation. Thank you. That was quick. That was great. Okay, on the next one, it's going to be 2/5 plus 9/10. 2/5 plus 9/10. What do you get? 13/10. And there's your answer. That's how you leave it. You're done. Don't make that more complicated than it is. Okay, guys. So by the time we get these out, you're not really going to have time to work, but you're going to see when you get the worksheet, I cut it way down. It was like 17 problems, and I cut it way down. As soon as you get it right on it before you pack up. Now, listen to me. Write your name, date, period, and assignment number clearly on this. Okay? Please make sure you do that and have it done. Clear this stuff out. Yes. Yes. Yep. Just take it home, put it in a drawer somewhere, have it ready to go. Whoa. 2, 3, 4. You're like 5 miles away. Okay, guys. So, thank you for the question.